Thank you for joining, everybody. My name is Scott Alexander. I'm from Optimity Advisors. And if you've reached the Strategic Value of Process Simulation webinar, you are in the right place. Thanks for joining this morning or afternoon or wherever you are. Over the next hour, we'll be roughly walking through these areas around process simulation. So we'll talk to what it is, talk to how how we put it into practice in the real world, talk about some of the best practice extensions of it, and then, as promised, in how we reached out to you, we'll walk through a fair amount of use cases across different industries around process simulation, extend that into a case study, and then leave time at the end for Q&A. However, as Luke mentioned, there is a Q&A button at the bottom of your screen, so you can use that at any time, ask a question through that, and then Ryan, our moderator, will frame it up for us. So please feel free to be interactive with this, and don't think that you have to save your questions to the end. All right, as I mentioned, I'm Scott Alexander with Optimity Advisors, and joining me is Luke Hermiston, a manager and one of our process optimization experts that we have on our team. And so we'll be trading off across different topics during this session. So before we dive into simulation, it's fair to give you the 30-second commercial on who Optimity is. We're basically a digital innovation consultancy. We cover a number of industries, from healthcare to financial services, media and entertainment, and consumer brands, being probably the foremost industries that we hit. But basically, across any of them, we take a slightly different approach to digital innovation. We build in the human-centered piece to it, so that the strategies and the solutions around digital innovation involve, consume, and are centered around those human areas. So that's one of the different takes on digital transformation, so to speak, that you'll hear from Optimity. And hopefully you'll see that reflected here in this topic of process simulation. So let's talk about what it is first, before we dive into the particulars. In fact, since this is a strategic value of process simulation webinar, let's talk about strategy first. So to back up, any business strategy drives basically two objectives. The first is you've got to figure out how to get the right products to the right customers. So what market are you serving? And for each of those markets or micro markets, ideally, what products that you or services that you create are the best fit for that set of customers. And the second objective with any business is to deliver them as efficiently and effectively as possible. So find the right customers and get the goods and services to them effectively. And in the past, that's been done through really a series of cycles, of predictions. We think these are the right customers, or we think these products will be a good fit. And we think that this way to manufacture them, or these services, the way we do them in these processes today, will get it to them in the most efficient manner. And then we try it, and we get evidence back or data back. We evaluate it and make further decisions. So those cycles, as all of you know, happen hundreds of times during a day in each of your jobs. And so aggregated across your companies, there are a lot of cycles of prediction, evidence, and decisions. What process simulation simply does is accelerate those, so that you can make those decisions around customers or products or efficient processes to deliver faster, cheaper, and more accurately than you could before. So essentially, that's how process simulation fits into strategy. So what is it and what does it do? It essentially is, think of it as Visio on steroids. It essentially is a visual graphic mock-up of your process. Looks like a process flow, and you'll see examples of it throughout the session that we do, but uses real data, cycle time data, arrival rate, logic around different routings, all of this different kind of data that you can incorporate into this mock-up to make it come alive, so to speak. And then what that does is it allows you to actually quantitatively represent how your process flows as opposed to just visually looking at it. And then you can do this across a number of time frames, from a day to a week to a year. And what that does is it allows you to actually make predictions after you get the current state of the actual simulation established. Then you can run a number of what if scenarios, and those what if scenarios enable you to predict the end-to-end outcome in each case. And ideally, that helps you deliver the best results. So we'll show you examples of that as we walk through. And so given that, that we're talking about embedding process simulation in your strategy, and that you can use it in a way that makes an actual process description or graphic come alive, we can probably divide the actual value that you get out of it into two categories: operational and financial. So in the operational end, basically it's less, the essence is running a simulation model or multiple models is less costly than trying it out in a real life implementation. I don't think anybody will argue with that. It enables you to test different ideas before you actually have to build them and implement them. And it determines impacts across the varying time frames, as I mentioned, in areas of cycle time, throughput, end-to-end, SLA achievement, as well as decisions around staffing and being able to fulfill products or services using a certain level of staffing. And it does that in an impartial way, meaning it uses data to figure out whether you're going to make a certain throughput SLA or whether you have enough staffing, as opposed to a thumb in the air approach. So operationally, that's an advantage of simulation. From a financial side, you can also plug into these models as you're simulating and making scenarios on different flows. You can plug in the cost of each of those materials or the cost of the staffing to operate that particular process. So literally, you can assign a cost to each element that flows through the model. You can also do the same thing with revenue. So if you're producing shirts or jeans, and you've calculated the cost of the process, you can also assign a certain revenue to each widget, so to speak, flowing through the model. And of course, if you have cost and you have revenue, you can calculate ROI and profit before you start investing and budgeting large amounts of money. This, we have, in our experience, tends to create a lot higher stakeholder communication and a lot higher buy-in. If they literally see visual evidence of how a process or a set of processes is going to operate before investing in them, it makes it a lot easier to make a budgetary decision. So essentially, in summary, the outputs that you get from process simulation that we believe are strategic is that you've got real data of the models that can predict the outcomes and test various what-if scenarios that essentially reduce a lot of risk, take a lot of risk out of a proposed effort that whether it's part of a lean continuous process or continuous improvement program or just out of individual process improvements. Risk is always a big area to consider, and these models tend to take the risk out. As we mentioned, it informs business decisions and drives efficiencies in areas where it would be tough to discover what the answers are unless you modeled it, and helps the actual business case develop in a more quantitative, believable manner. So at this point, we've talked about what process simulation is and why we think it's strategic. Luke's going to walk through some examples of how we've actually put it into practice. Take it away, Luke.
Thanks, Scott. So 3 of the most common ways that process simulation capabilities can be embedded within the organization are embedding a role or team within a department or functional area. This is great when continuous improvement is really the core competency of that department or functional area. Examples include manufacturing, supply chain, and operations improvements functions. Another option is the center of excellence. This is a great approach when you have a lot of different departments and functions that need simulation technology, but not really frequent enough to need an embedded role on that team or to have that be an embedded function of the team. So where you might see this is at a large insurance organization where they need to farm out the simulation and process improvement function to their claims team, to their customer service team, or to their enrollment operations team. And they need to look at a couple scenarios, improve processes for a period of time, and then maybe it's not a full-time ongoing lean initiative. This also makes sense for hospitals when you have a lot of care pathways and functional areas that need to work together, but maybe don't need to solely improve themselves. So a large system that needs to be improved. The third way you can kind of develop the capability within your organization is a one-off engagement. These are examples where you have a specific scenario or process or large investment that you want to explore, and you really need to dive in, develop a solid business case, and understand what you may be implementing prior to its rollout. One example is COVID-19 impact modeling, and another use of this kind of engagement would be testing the capability prior to developing a center of excellence or embedding the capability within a department. This is also great because you can get training while doing the one-off engagement. So how do you actually stand up process simulation, or how does the process simulation process function? First step is to gather data. You're researching and doing chairside observations, gathering cycle times, throughputs, handoffs, and the processes that people and systems are going through on a day-to-day basis. You then map and model this data and these process flows into the technology and validate that with the teams you collected the data from. You move forward to scenario testing. So whether this be a change in inputs, or it's a change in a process, or you just want to understand maybe if we did X or Y happened, how might that impact the entire system? This is where you run those scenarios through. And then you propose and implement these improvements. So you develop the business case, you implement the change, and then depending on the type of need your organization has, you're continuously testing and improving this throughout this cycle of steps. The outputs at each step, when you're gathering the data, you have an organized data on each of your individual process steps, the inputs, outputs, throughputs, all the things like that. You're also documenting your KPIs. Regardless of if you're using simulation or not, these are great things to have for business process management and improvement purposes, regardless of how you intend to apply them. This ensures you're validating the current state. Then when you're mapping and modeling, you get those process flows and they're in BPMN format, which basically just means you can import and export them to any of your process flow technology, whether that's a business process management tool, an ERP tool, or a Visio and static tool as well. And then you can, use those to validate the current state simulation, as well as understand all of your existing process flows, handoffs, and decision points. From there, you go into scenario testing, where you're getting a results table of the scenario impact on the KPIs that you've identified. This allows you to understand the outcome of potential changes or scenarios that you're running through the model prior to investment or prior to them happening. From there, you can identify the highest impact opportunities within whatever system or process you're modeling, and really map out the expected benefits and impacts from the changes you want to make. And this is really useful for benefits realization tracking down the line, as well as developing more solid business cases and understanding the improvements you're intending to get prior to making the investment. So we're going to stop briefly for a poll with 2 questions. The first question is, does your organization have an ongoing lean or continuous improvement initiative or center of excellence? This could also include, operations improvement efforts and things like that. You should see the poll pop up on your screen now. We'll just give it a little bit here to let everyone answer. And then the second question is, what role do you play in your company's lean or continuous improvement effort?
We'll give it another 30 seconds here, Luke.
Great, thanks, Ryan.
Hey, Karen, no worries about not being able to submit. It must just be something going on with the polling, but I'm seeing other people are able to submit. So thank you all for your answers so far. All right, I'm going to share the results here.
All right, so it looks like this is definitely something that's going on in people's organizations, and that's relevant, which is good. It's good that people are learning about something relevant or hearing about something relevant today. Moving forward, it's a sample simulation. This is just one we have for demos. The ones we develop for real life scenarios are generally a lot more complex, but this does a good job of showing, here's your process flows. You have your intakes, your queues, and the processing areas. As the balls are moving across, those are specific work items. So whether that be a form, in this case, it's healthcare enrollment. So these are forms, pieces of mail that are then scanned, moved through, and then processed by manual workers and QA workers. You can see the errors here, the corrected errors, and it really just lets you see where things are queuing up, where your issues might be. So here you have 46 pieces of mail, but you have nothing on the teams or waiting for QA. So clearly you want to kind of increase the mail room and move things through quicker. So that's just a quick example of a very simple simulation. We have some more complex ones later on. So example outputs from past simulation projects. Again, this is an enrollment effort at a large insurance company. And what they were really interested in was looking at how to reduce the time from receiving an enrollment change or a new enrollment and how long it takes to cycle through that, and how they can optimize their staffing. So we developed with them 10 recommendations. And then as these recommendations were ran through their real life data and system, we found that if they were to implement all of these, they could get the cycle time down to 2 days, and the open season or open enrollment cycle time down to 3.3 days. And then while doing this, they could also improve the utilization and optimize their staffing by moving people around within the department. There were too many people in the processing, not enough people in QA, so there was a bottleneck in QA, and time to enrollment was getting delayed specifically for that, as well as identifying some technology to improve the overall processing time. So I'll hand over to Scott to dive in a little further into the best practices in process simulation.
All right, thanks, Luke. So Luke gave you just a quick snippet on how we've actually deployed this or used it in real life scenarios. As he showed the model example, that was an enrollment optimization process or lean effort that we did. That albeit that's a very simple example, but one of the advantages is you can build this out as complex as is needed by the process. So that really dovetails into, I would say, 4 best practices that we can surface. There are probably more, but given the time that we have here, these are probably the 4 main ones. First is that you got to think of process simulation as a continuous effort. It's not a one and done. Just by nature, if it's part of a lean program or initiative or continuous improvement initiative, ISO 9001, whatever you call your continuous improvement, it's meant to build off of the previous efforts. So once you improve a process, it's meant to be able to simulate the next round of improvements and then figure out what you need to do from there. And that works well with existing BPM systems. For example, Pega or Agilent or Appian, AgilePoint, any of those K2 that are common BPM systems in the market that some of you may actually already have installed. Existing BPM systems may have their own simulation modeling tool within them, or they may not. And you can use simulation modeling best of breed tools, or we would call them standalone, except that they integrate in, which we'll talk to here in a second, with existing BPM systems. So to leverage a BPM system it is definitely to your advantage, whether it's got the simulation built into it or not. And then what we've also done is, in addition to the straight process modeling that you saw Luke walk through, we've also added in parallel a user prototyping design approach, especially in processes where there's a fair amount of manual human work, along with potentially some automated or semi-automated work. The user prototyping is a design thinking approach to ensure that the user's efforts, constraints during the day, and most importantly, objectives are met as a part of the actual overall workflow process design. And then lastly, but certainly not least, each of you probably has in some way, shape, or form an artificial intelligence or machine learning effort afoot in your companies. Or if you don't right now, you soon will. Many research analyst groups focusing on artificial intelligence predict that every business will be in some way, shape, or form an AI business within 10 years. So it's not if it's coming, it's when. And it turns out that process simulation is a perfect close cousin and worker of machine learning information and efforts. So we'll walk through some of those as we go here. In essence, this is how a simulation approach would work if you're pulling in data from, say, a BPM system. Many of these BPM systems output them either directly from the database, from Excel pulls, whatever it is. But over on the right, or I'm sorry, on the left, the ability to pull real operational data from that BPM system, as well as walk through the process routings and workflows and more or less quantitative observations by the workers is valuable as well. But that helps you establish a solid current state process. And then in parallel to that, you're working with the users there in the center where it says rapid prototyping iterations in a cycle that involves how those users and the personas map in terms of their own journey, their own process journey, creating process mock-ups to present to those users, and then continuing that cycle so that all of the user needs are infused, so to speak, into the future state processes and simulations that that are involved in the model. And so you've got both the hard data from the BPM system or collected in some other way, and the softer data or needs about the process collected from the user design workshops that you then filter into the future state simulations and scenarios that essentially are the current state simulation tweaked or changed in a way that is proposed either by the group of users you're working with or proposed by the team that's running the actual project. Either way, you can produce 1, 2, or 3 future scenarios, or 30 or 40, however many you need to get to a quantitative, data-driven view of an optimized process that's reflected over there on the right. So that's a very quick overview of involving BPM as well as the user needs as a best practice with simulation. Let's talk a little bit about AI and machine learning. So take what I just talked about when we're creating simulation models, both the current state and then future state what-if scenarios, and now plug in machine learning algorithm trained data from that same BPM operational data that produces basically process activity trends. So if you look at a process as multiple activities and multiple steps, multiple paths, artificial intelligence algorithms are great at ingesting a large amount of data and then starting to produce trends or even categorizations from that data. So once that's done, what do you do with that data? What do you do with those trends? And that's quite honestly where a lot of AI POCs or proofs of concept just stay proofs of concept, because people get the trends and they don't know what to do with it. Well, process simulation is a perfect ingester, so to speak, of those artificial intelligence trends. So if you integrate those AI trends into the back end of a of a process simulation model, you can actually take those individual activity trends and plug them into the same activities that you saw in the previous simulation models that Luke showed. What that does is it makes your simulation model come alive, so to speak. Whereas if you set up your simulation model activities before based on either hypothesized cycle times or feed rates that you collected manually, now you can take actual changing, trending, real operational data from these AI models and make the activities in the simulation model reflect those same changing and trending positions. So in essence, what you've got is your simulation model is first a great collector and user and implementer of that AI data. It also tunes the simulation model better and better and better as those machine learning algorithms learn and trend and get better over time. So as your machine learning improves in its ability to predict, so does your model. so does your simulation model. And this is where the power really comes in both artificial intelligence, machine learning, and process simulation. So with all that said, examples of where it's been implemented and some of these best practices we've talked about, where do we start? What do we do? So this is not meant to be an exhaustive list, but it is meant to get you started down the road. And any simulation project should basically search out and try to simulate and analyze end-to-end performance processes with end-to-end performance measurements that matter. So in other words, if you've got a critical process where the service level agreement needs to be hit, or there are fines that are dished out either by your customer or a federal regulation because you don't hit that SLA, then that end-to-end performance definitely matters. And that might be a good target to build a simulation model around. Similarly, if you've got a process where downstream decisions that impact especially customers, but also employees and partners are critical, in that you need to know that your throughput means that you're able to fulfill product shipments within a certain time, or that any efficiency changes you might make may mean a cutback in staff, or a displacement in staff, a move in staff, like Luke mentioned in the enrollment model. Those are downstream decisions that impact employees. Similarly, with customer service, if you're changing how those particular CSRs take calls and how it's staffed, that could impact customers. So these are examples of processes that are absolutely ripe for process simulation. Thirdly, that have robust operational data for model creation and improvement. And really the example of that is what we just talked about in artificial intelligence and machine learning. The ability to be able to pull that operational data continually off the actual BPM system, or whatever it is that's running the operation, is critical to continually build the accuracy of the model. And then lastly, is as almost counterintuitive as it sounds, containing complex workflows and processes within interconnected systems. Literally, the more complex the process is, the more intertwined it is, the more valuable your simulation model is. And the reason is that if you were to try to take a complex interconnected end-to-end process and figure out how it was going to perform end-to-end with a spreadsheet, or by anecdotal conversations, that would be hugely hard. Or if you were to create your own custom-built application to do it. But with process simulation, you can assemble these facsimiles of the process together pretty quickly, as quickly as you can a Visio diagram, and simulate something very tough to duplicate anywhere else in a fairly short period of time. So literally, the more complex it is, the more it makes sense to build a simulation model. Go ahead, Luke. Okay, that's a bit on best practices and how to get started. Luke is going to walk through, and I will walk through use cases, so real life examples within different industries of where it applies. And these are not meant to be all exhaustive. These are just ones that we picked out that it seemed like cleaved to both experiences we've seen as well as the audience on this particular webinar. Go ahead, Luke.
And Mary, I saw that you raised your hand. there's a Q&A function, so you can type in any question you have, and we'll also have a speaking Q&A at the end. Here is a brief, looks like the question
Hey,
just.
yeah, hey, Luke, why don't we answer it? I know there's a question right here about, it says, very useful presentation. Would like to be going back to it from time to time after this webinar. Can the attendees have access to the recording? Yes. And do we have an orange paper or a white paper about it? That answer is yes as well. And that actually one of the shorter orange papers you had access to if you registered. And the second one, which is about the value of simulation, we will have posted on our own Optimity website. So sorry to hit that right away. Go ahead, Luke. So I'll go ahead. Oh, go ahead, Luke.
Thanks. There's use cases across industries, and you can see them here. We're also going to talk to them in detail, so we'll just dive straight into those. The first one we have is consumer goods and supply chain. I'll let Scott speak to this briefly.
Sure. This is meant to simulate actually a client of ours that is that works clothing and apparel across the entire what I call end-to-end spectrum of the typical retail supply chain, from manufacturers, whether they're either in the U.S. or or offshore, depicted over there on the left, and also driven by the demand planning process that this particular company has, and the purchase orders they create, all the way as you go to toward the right through their own distribution warehouses. One set of warehouses for online sales, another set for of warehouses for their actual B2B customers, which might be, you know, Penny's, Macy's, whoever, or their actual stores where they sell their apparel. But yet another example of how you can put together a simulation model that shows the end-to-end operation and can simulate the flow of any item, whether it's purchase orders or actual shipments of goods or sales of goods across the entire spectrum. It's important to point out that this is, even though it looks somewhat involved from the end-to-end level, each one of these activities can break out into its own sub-process and sub-simulation. We'll show you an example of that a little bit later on. But in essence, this would probably break out to 7 or 8 even more detailed simulation models that then can be linked together and aggregate up to the one you're seeing here. We also coupled the actual material supply chain flow from left to right with a marketing campaign flow, because most, especially consumer goods companies, have marketing operations. And typically when you're trying to get goods to the stores, many times you're trying to create a campaign or some sort of marketing effort to move those goods. So simulation can also be applied to those processes in marketing to make sure that you're moving, creating your digital assets, going through rights management, and distributing those assets down to whether it's assets that you're distributing to the end retail stores, or even sending to a printer to advertise a buy one get one free for the shirts. That those hit at the same time the actual apparel, in this case shirts, gets delivered to the stores. So it's useful for the marketing ops as well. In fact, you can aggregate the two together. Luke, can you go ahead and just run this real quick? This looks a lot like the enrollment one that you saw before. In each case, the red balls represent either, in this case, purchase orders from demand planning or actual shipments from manufacturers to either the warehouses, either online or brick and mortar. What we've done here is we've shown the plug that is actually occurring today, where retail is simply not selling at the rate that they were before the COVID-19 virus hit. And we're simulating the bottlenecks that would build up at the distribution points, given the fact that the retailer probably ordered a lot of these ahead of time from the manufacturer offshore, but can't get the sales flowing from any of the brick and mortar units due to the decline in demand. So the example of the breakout is one actually in the store, and this looks simple, but it's another way that you can show how that particular model can break out into a submodel. This happens to be just the point of sale piece. Media, believe it or not, applies to being used for process simulation. If you think about a media event, whether it is the Super Bowl or the Olympics, it really is a flow of people and materials from one point to the other, all culminating in a single event. And there's a lot of complexity and scheduling to get that done. So simulation modeling can apply there as well, where you're trying to pull together all of these different crews, cameras, lighting, equipment, etc., all at one point, and do it cost effectively and with the right level of staffing.
So the next use case is emergency care in the hospital setting. The real focus of emergency care is making sure you get patients, whether they have a stroke, heart attack, or traumatic event, into the hospital within an hour or as short of a time as possible. And so what simulation allows you to do is map the end-to-end system. You could even include external hospitals for purposes of overflow routing. And you can understand that depending on how frequent the inbound patients are within a specific time and where they're coming from the city, what can we meet the time? Do we need to go to overflow routing? And what are the competing resources between the care pathways that may limit care delivery? The emergency responding team sometimes can be impacted, and where simulation is really useful here is that you can include a lot of your care pathways or all your care pathways and see the impact between each other. This is great for emergency care, but there's also a lot of applications outside of that where whenever you're dealing with beds, theaters, and staff, you really need to understand how they're tied together and how they're impacting each other. And this is just the outputs of a different model that looks at the entire emergency room and identifies, what is the utilization of your doctors, nurses, and triage, and what is the reasons and the percentage of the time being blocked for various impacting things. And what's great with this is, you can tie in your entire hospital operations to really not work in isolation. I think different departments and groups tend to think that they only exist within a bubble, but this really ties everything together and can tie the whole system's impacts on each other. And you can understand the impact of changes outside of just your group. The other use case, this is, again, the insurance enrollments one, but it applies to all manual processing within organizations. You can map out what your processing teams are doing and then understand where they're having problems and where they're getting bottlenecks and look at opportunities to improve those. So if it is in the processing of mail, maybe you want to get a OCR, ICR technology that can scan and read the mail faster than maybe a person can, so that you're sorting at a more rapid rate and you can get the documents that need to be processed to the teams faster. There's applications of this both on the insurance side for claims, enrollment, and customer service processing, as well as the provider side in billing and administration. So kind of both sides of the spectrum there. And then once you've reviewed these opportunities, you can develop pretty robust business cases that will tell you almost exactly what benefit you're looking to get and compare that with the cost of either hiring new staff, implementing new technologies, repurposing staff to reduce cost, things like that. So there's a ton of applications in any area where you're processing a lot of forms, documents, and phone calls. So we're going to go back to a poll here. Has your organization ever deployed process simulation tools in the past? We've just laid out some of the common tools that are used, but if you've used another tool, feel free to write other. We'll aim to get into the Q&A session here in a minute.
See some results coming in. We'll give everyone another 30 seconds here. In preparation for the Q&A, like Luke and Scott have said earlier, there is a Q&A functionality that you should see at the bottom of your screen. If that's not working for you, feel free to use the chat function and we'll try to monitor in there as well.
And Ryan, I think we can, if people raise their hands, I think we can just unmute them and they can say their questions if they
yeah,
don't. No
problem. I'll share the results of the poll now.
Great. So looks like most attendees have not had their organizations use simulation tools in the past, but hopefully, at least today, we've sparked an interest, and you can see how it could be applied at your organization. We have one more use case, but I think we'll just go straight through it. This was about, again, insurance operations, specifically modeling COVID-19. What you can see here is that there's a lot of variability, and there's going to be major fluctuations in the claims that are coming in, the volume, the types of claims that are coming in, as well as local, state, and federal policy change. And these things are changing every day. So how do you rapidly test what these inputs might impact your complex system? Because you have operations and enrollment, customer service, and claims. How do you model all these things at the same time? And it's just laying out how simulation is a really good tool to do this. Here you can see the impacts of various scenarios, where you might see the cues, things like that. We'll also circulate the deck, so if you'd like to review this later, the slides do speak well for themselves. And here we're just highlighting where you can see the backups and the cues, and then if you were to implement some specific changes, how those backups and cues might change, and the business case for maybe making some specific changes to your operations. So in conclusion, you can predict the future and reduce today's risk in a rapid, data-driven way that lets you test and understand changes prior to making them. With that, we'd like to open up the QA and hopefully answer some questions that people might have. If you'd like to just write into either the QA box or the chat, we'll allow you to unmute you, and you can ask your question, or you can just put it in writing, whatever's you prefer.
Hey, Luke and Scott. I had one come in through the QA. Somebody asked, what are some AI use cases that fit well with process simulation?
Well, we've tried to incorporate a few just here in this this short presentation. A big one, of course, is supply chain. Now, the supply chain one that we showed earlier, what happened to be retail from manufacturer all the way through distribution, but manufacturing in industrial products is a big one as well, within the actual manufacturing floor. The process simulation tool example you see here is one called Simulate. If you go to their website, they actually have samples of directly of manufacturing operations where simulation, saves, as the conclusion mentions here, a lot of money in investing in a lot of tooling, et cetera, before you actually have to invest. So it enables you to test before you lay down big bucks, so to speak. Another big one is that it's pretty universal across a lot of industries is call centers or customer service, where literally it is a demand of customer queuing requests compared to capacity of ability to handle and resolve those requests. Another great example of where you can simulate the incoming demand versus the staffing or automated ability to pass those requests on and either handle them in tier 1 or pass them on to tier 2 or 3. So those are two. The ones in the back office, probably a third would be, there's a lot of back office work in admin, forms ingested via mail that have to go through approvals, whether they're regulation, et cetera, in financial services, whether that's banking or wealth management, where you're transferring one account to another. And it's a good example of things that are a combo of automated as well as manual. If you've got robotics running any place in your organization, that's another ripe field for tapping on simulation, because the robots themselves are producing data around how well they handle in their micro automation environment, as well as the manual pieces that are being fed to it. And you can simulate that end to end to see where the bigger picture bottlenecks are occurring. So those are three. And of course, if you have others and you think of it after this session, we have our phone numbers up and emails that you can contact us. Any others?
Yep, we just had one come in from Jonathan Kaplan. Thanks, Jonathan. Jonathan asks, on the COVID case study, are you also modeling costs to an insurer from claims losses and loss adjustment expenses related to settling claims, or is that not part of the process simulation?
What we're modeling there, and you can chime in here, Luke, on the COVID case study, we're primarily modeling the variability of the incoming claims due to anything from CMS not paying or seeing us paying for particular services to confusion with providers that are submitting claims in a different way, so they have to be manually reworked, to just flat out fraud that we know will be happening as a result of COVID. So your question on cost to an insurer from claims losses may be in, and this is health insurance that we model, obviously, but not property and casualty. So the losses in those claims insurance that we do have modeled would probably tie to either fraud or abuse, where it's just a mistake on the provider's part in their coding of their diagnostic services, or
I'm just
staffing.
I'm reading the question in more detail, and I think, Jonathan, good to hear from you again, and hope you've been well. But the process simulation can really tell you a lot about how many, how long, and how often, and it then can take complex data. So you'd probably have to make another model to actually run the analytics on the claims losses and that complex cost scenario. But then you can tie in that entire model that you have into the simulation with a range of statistics and say, okay, everything that goes through here, maybe 20% or a normal distribution from 10 to 50% or whatever is accurate can be tied to that, and then it'll spit out a series of results based on the model you tied into it, as well as the simulation dynamics. Does that answer the question?
And sounds like one, Jonathan, thanks for that additional piece. It sounds like one that we could take offline too and walk through in more detail. So happy to do any of those.
Great question. Let's walk through as well.
Right.
We are coming up to the end of the time. It looks like we have one more on. Yeah, great. Okay, so just following up. Anyone other questions from anyone online? All right. Well, thank you everyone from the time today. I appreciate it. I know everyone's quite busy with everything that's going on, but it was great having the questions and the discussion with everyone today. And we'll be circulating some follow-up documents, the white paper, and the recording, and some other things as well. So thank you, everyone. It was great talking today.
Thanks for your time, everybody.